Good morning, students. In the last class, we stopped in the question 9, that is derivation J is equals to sigma E, right? So move on to the next question, that is 10th question, right? So explain with the circuit diagram how to convert galvanometer into ammeter. So first one is ammeter and the second one is voltmeter, right? So what is ammeter? So ammeter is a device which is used to measure the current in the circuit. So ಯಾವುದಾದ್ರು ಒಂದು circuit ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇದೆ. ಸೊ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ಮೆಜರ್ ಮಾಡೋಕೆ ಯೂಸ್ ಮಾಡೋ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಯಾವುದು ಅಂದ್ರೆ ಆಮ್ಮೀಟರ್, ರೈಟ್? ಸೊ ವೋಲ್ಟ್ ಮೀಟರ್ ಮೀನ್ಸ್ ವೋಲ್ಟ್ ಮೀಟರ್ ಇಸ್ ಅಗೇನ್ ಇಟ್ ಇಸ್ ಅ ಡಿವೈಸ್ ವಿಚ್ ಇಸ್ ಯೂಸ್ ಟು ಮೆಜರ್ ದ ವೋಲ್ಟೇಜ್ ಇನ್ ಎ ಗಿವನ್ ಸರ್ಕ್ಯೂಟ್. ಸೊ ಯಾವುದೋ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಗೆ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಆಗಿದೆ ಅಥವಾ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಆ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ಮೆಜರ್ ಮಾಡೋಕೆ ಯೂಸ್ ಮಾಡೋ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ವೋಲ್ಟ್ ಮೀಟರ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ಫಸ್ಟ್ conversion of galvanometer into a voltmeter. So galvanometer, it is a device which is used to detect the current. So measure the current and detect the current. Two difference ಇದೆ. So galvanometer ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ? Only to detect the current. So circuit ಅಲ್ಲಿ current flow ಆಗ್ತಿದೆನಾ ಇಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡೋದಕ್ಕೆ ಮಾತ್ರ ನಾವು galvanometer ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ammeter ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಎಷ್ಟು current, so how much quantity the current is flowing in the circuit ಅನ್ನೋದನ್ನ ಮೆಜರ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ammeter na use ಮಾಡ್ತೀವಿ. So that is the difference between the galvanometer and ammeter, right? So question number 10, right? Conversion of galvanometer into ammeter, right? So we are converting the galvanometer into the ammeter. So now galvanometer in the ammeter ge convert ಮಾಡ್ತೀವಿ. So that's why first we are going to take one galvanometer, right? So galvanometer is denoted by G. So to this galvanometer, so in galvanometer ಒಳಗಡೆ ಏನಿರುತ್ತೆ? coil ಇರುತ್ತೆ. So coil is nothing but the conductor. So that conductor has some resistance. So that resistance we can write in the external. So we represent the resistance of the galvanometer. So inside ಅಲ್ಲಿ ಏನು resistance ಇದೆ ಅದನ್ನ ನಾವು external ಆಗಿ represent ಮಾಡ್ಕೊಂತೀವಿ, where Rg is the resistance of the galvanometer. So G suffix ಅಲ್ಲಿ ಏನು indicate ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ galvanometer. So R is the resistance. So ಇದು ಯಾವ resistance ಅಂದ್ರೆ galvanometer resistance. So this overall combination ನಾವು ಏನಂತ ಕರಿತೀವಿ? Galvanometer, right? So now how we are going to convert this galvanometer into ammeter, right? So by connecting a small resistance in parallel with the galvanometer. So in galvanometer ಗೆ ಒಂದು small resistance na connect ಮಾಡ್ತಾ ಇದೀವಿ, that we call as the shunt resistance, right? So small resistance, that's why we are taken small r. So value capital R ಇತ್ತು ಅಂದ್ರೆ it has the larger value. So small r indicates what? It has less value, right? So connecting the shunt resistance parallel with the galvanometer, right? So now this overall combination behaves as ammeter. So these two combination ಯಾವ ತರ behave ಮಾಡ್ತಾ ಇದೆ? Ammeter, right? So this is simple construction. So how to convert the galvanometer into ammeter? To convert the galvanometer into the ammeter, so connect one shunt resistance or small resistance in parallel with the galvanometer. So adon statement ಬರ್ಬಿಟ್ಟು diagram, right? So diagram ಬರ್ದು so mathematical relation ಬರುತ್ತೆ. So how much quantity the resistance we are going to connect ಅನ್ನೋದನ್ನ mathematical relation ಬರುತ್ತೆ. So ಅದನ್ನ represent ಮಾಡಿದ್ರೆ so we converted the galvanometer into the voltmeter, right? So where I is the current which is flowing in the circuit. So this is the junction. So at this junction current ಏನಾಗುತ್ತೆ ನಮಗೆ divides ಆಗುತ್ತೆ because we have the two branches of conductor, right? So two branches of the conductor ಇರೋದ್ರಿಂದ current ಆ junction ಅಲ್ಲಿ divide ಆಗ್ತದೆ, where Ig is the current which is flowing in the galvanometer, right? So Ig ಅಂದ್ರೆ ಯಾವುದು? The current which is flowing in the galvanometer. To this current galvanometer shows the deflection, right? Next, so in the another branch which is connected parallel to the galvanometer, so that is from the Kirchhoff current law it becomes I minus Ig, right? So in junction ಅಲ್ಲಿ current divide ಆಗ್ತಾ ಇದೆ. So total current I flow ಆಗ್ತಾ ಇದ್ರೆ galvanometer ಅಲ್ಲಿ Ig current flow ಆಗುತ್ತೆ. So remaining the resistance list flow is I minus Ig, right? So from Ohm's law, so here to parallel the potential across this end. So ಈ end ಅಲ್ಲಿ potential ಎಷ್ಟಿರುತ್ತೋ so parallel ಎಷ್ಟೇ branches ನಾವು connect ಮಾಡಿದ್ರು potential ಎಲ್ಲ branches ಅಲ್ಲೂ ಏನಿರುತ್ತೆ same ಇರುತ್ತೆ, right? For example, if you have taken the junction AB, right? So the potential across this junction AB has some potential means, so the same potential will be across the resistance R. So ಇಲ್ಲಿ ಎಷ್ಟು potential ಇರುತ್ತೋ ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ potential ಇರುತ್ತೆ. So if we further connect two or more branches in parallel with this galvanometer, means again in all those branches the potential will be remains same, right? So V same irutte. So from the Ohm's law, V is equals to I into R. So Ig into Rg, that is equals to I minus Ig into R, right? So we can write that one Ig into Rg, that is equals to I minus Ig into the resistance is small r, right? So we are going to calculate this resistance only, right? So R is equals to Ig Rg divided by I minus Ig. So this is how we converted galvanometer into ammeter, right? So next thing, conversion of galvanometer into voltmeter, right? So here R is what? Small resistance. In other words, we also call this one as shunt resistance. So ಅದನ್ನ small resistance ಅಂತ ನಾವು ಕರೀತೀವಿ ಅಥವಾ shunt resistance ಅಂತ ನಾವು ಕರೀತೀವಿ. So small R indicates what? The small resistance which is connected in parallel with the galvanometer, right? So how we convert galvanometer into voltmeter? So ನಮಗೆ example either they may ask for the ammeter or they may ask for the voltmeter, right? So ಇದರಲ್ಲಿ ಯಾವುದು ಒಂದು ಕೇಳ್ತಾರೆ, right? So ಎರಡನ್ನು ಗೊತ್ತಿರಬೇಕು. So again we are going to convert the galvanometer into voltmeter. So first we consider one galvanometer. So G is the galvanometer and Rg is the resistance in the galvanometer, right? So now high resistance is connected in series with the galvanometer. So one resistance na connect ಮಾಡ್ತಿದೀವಿ, so that resistance is high resistance. So high resistance in the, that's why we take a capital R. So here high resistance is connected in series with the galvanometer, then this whole combination acts as the voltmeter. So these two combination ಯಾವ ತರ ಬಿಹೇವ್ ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ ನಮಗೆ voltmeter ತರ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ, right? So ammeter ಗೆ small resistance parallel ಆಗಿ, voltmeter ಗೆ large resistance series ಆಗಿ. So connecting the large resistance in series with the galvanometer, then the galvanometer behaves as voltmeter, right? So when Ig which is flowing in the galvanometer, so current ಏನಾಗ್ತಾ ಇದೆ galvanometer in the galvanometer will flow ಆಗ್ತಿದೆ, hence we take an Ig, right? So the potential across the ends of the circuit, so AB series alide, so overall potential this V is equals to, so potential V that is equals to, so current which is flowing through the resistance of the galvanometer and the resistance which is externally connected to the galvanometer, right? So series ಆಗಿರೋದ್ರಿಂದ we can take the combination of resistance, that is Ig into Rg plus R. So we need R. So ನಮಗೆ ಬೇಕಾಗಿರೋದು ಯಾವುದು? Capital R. That is how much resistance we are going to connect in series with the galvanometer, right? So if we simplify this relation, if we shift Ig to the LHS, it becomes V divided by Ig, that is equals to Rg plus R. So we need R. So shift this to LHS, it becomes V by Ig minus Rg, right? So where R is the large resistance. So ಇದರಲ್ಲಿ ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು ಅಷ್ಟೇ, ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್? ಲಾರ್ಜ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಸೊ ಅದನ್ನ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವ, ಪ್ಯಾರಲಲ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವ. ಸೊ ಯಾವ್ದು ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ? ಗ್ಯಾಲ್ವಾನೋಮೀಟರ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ವೋಲ್ಟ್ ಮೀಟರ್ ಅಂದ್ರೆ ಲಾರ್ಜ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಸೀರೀಸ್ ಟು ದ ಗ್ಯಾಲ್ವಾನೋಮೀಟರ್. ಸೊ ಗ್ಯಾಲ್ವಾನೋಮೀಟರ್ ಗೆ ಸೀರೀಸ್ ಆಗಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇನ್ ದ ಸೇಮ್ ವೈಸ್ ಆಮ್ಮೀಟರ್ ಅಂದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಯಾವುದಕ್ಕೆ? ಗ್ಯಾಲ್ವಾನೋಮೀಟರ್ ಗೆ. ಬಟ್ ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್? ದಟ್ ಇಸ್ ದ ಸ್ಮಾಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಸೊ ಸ್ಮಾಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವಿಚ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಪ್ಯಾರಲಲ್. ಸೊ ಇಲ್ಲಿ ಪ್ಯಾರಲಲ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇಲ್ಲಿ ಸೀರೀಸ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಇಷ್ಟು ನೆನಪಿಟ್ಕೋಬೇಕು. ಅಗೇನ್ ಫ್ರಮ್ ದ ಓಮ್ಸ್ ಲಾ, ಎರಡು ಕೂಡ ಓಮ್ಸ್ ಲಾ ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಾವು ರಿಲೇಷನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಿದೀವಿ. ದಟ್ ಇಸ್ ಫಾರ್ ದ ಸ್ಮಾಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಸೊ ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ ಅಂತ. ಸೊ ಇದು ಲಾರ್ಜ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆರ್. Right? So diagram important, right? So mathematical relation. So only 3 steps plus 1 diagram is there, but you need to explain G galvanometer. Rg is the resistance of the galvanometer, right? So here I will write Rg, resistance of galvanometer. So galvanometer conductor irutte, that is coil irutte. So coil ge resistance irutte, adu namage Rg agutte. So eradu kadegu same. So this will be inside the galvanometer. So idu ಒಳಗಡೆ irutte, but we are representing that in outside, right? So ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಸ್ ಅಥವಾ ಕೆಲವು ಗೈಡ್ಸ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ ಇದು Rg ನ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಲ್ಲಿ G ಇರೋತಾನೆ Rg ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ನಿಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗೋದ್ರಿಂದ ಇದನ್ನ ಸೆಪರೇಟ್ ಆಗಿ ಬರ್ಕೊಳ್ಳಿ. ಬಿಕಾಸ್ ಇಲ್ಲಿ Rg ಇದೆ, ಯು ಕ್ಯಾನ್ ನೆಗ್ಲೆಕ್ಟ್ ದಟ್ ಟರ್ಮ್, ರೈಟ್? ಸೊ ರಿಲೇಷನ್ ಬರೀಬೇಕಾದ್ರೆ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಹೆನ್ಸ್ ವಿ ಸೆಪರೇಟ್ಲಿ ರಿಟನ್ ದ resistance, that is the internal resistance of the galvanometer, right? So this is about the conversion, right? So ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು small resistance connected in parallel to the galvanometer, then the galvanometer acts as ammeter. So large resistance connected in series with the galvanometer, then galvanometer acts as voltmeter, right? So next question 11. So repeat agide, 1 marks allu repeat agide, 2 marks allu kuda ilide. Magnetic dip, magnetic inclination, right? So definitions ide. Next question number 12. Give an expression for the force acting on a charge moving in the magnetic field and explain the symbols. When does the force become maximum? That is a charge which is moving in a magnetic field, right? So that is question number 12. So this is by using the Lorentz force, the charge which is moving in both the electric field and magnetic field. So that we express as F Lorentz, right? So that is equals to, so elinda vandu kuda nanu mention ಮಾಡ್ತಿದ್ದೀನಿ, right? So Q into V cross B, right? So how we get the force when the charge which is moving in a magnetic field? So only magnetic field ಕೇಳಿರೋದ್ರಿಂದ this Lorentz force is the sum of the force that is due to the electric field plus the force which is due to the magnetic field, that is B, right? So here we need the value of B, right? So FB that is equals to Q into B cross B, right? So namage relation kelidare. So cross product of two vectors. So definition is the cross product of two vectors, that is equals to product of magnitude of two vectors and cosine of the angle between, so sine of the angle between the two vectors, right? So FB that is equals to QBB sin theta into n cap. So this is the expression we are going to write. So ಈ expression ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು, ಬಿಕಾಸ್ ಅದು ಡೈರೆಕ್ಟ್ ಆಗಿ ರಿಲೇಷನ್ ಕೇಳಿರೋದ್ರಿಂದ. ಸೊ ಈ ರಿಲೇಷನ್ ಎಲ್ಲಿಂದ ಬಂತು? That is from the Lorentz force. So we are deriving this relation from the Lorentz force. So Lorentz force is the sum of the electric force plus magnetic force when the charge which is moving in an electric field and also in the magnetic field, right? So here they also ask for the terms explanation, where Q is the charge which is moving in a velocity v in a magnetic field B. So Q andre ಏನು? Charge, V andre velocity, B andre magnetic field. So theta andre ಏನು ಅಂದ್ರೆ theta is the angle between B and B, right? So ಅದನ್ನು ಕೂಡ ಮೆನ್ಷನ್ ಮಾಡ್ತೀನಿ. Q is the charge, V is the velocity of charge, B is the magnetic field, right? So in ಮೂರು ಬರೆದ ತಕ್ಷಣ theta ಮಿಸ್ ಮಾಡೋಂಗಿಲ್ಲ. So we need to represent theta also. So theta is the angle between V and B, right? So velocity and magnetic field. So ಎರಡರದ್ದು angle ಏನಿದೆ ನಮಗೆ theta, right? So next is when the force is maximum, right? So magnetic force ಯಾವಾಗ maximum ಇರುತ್ತೆ ಅಂತ ನಮಗೆ ಹೇಳ್ತಿದ್ದಾರೆ, right? So maximum and minimum of the force depends on the sign of the angle, right? So ಈ ರಿಲೇಶನ್ ಅಲ್ಲಿ ನಮಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, sin angle ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, right? So when sin varies from 0 to 1, so value sin ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ವೇರಿ ಆಗುತ್ತೆ ಅಂದ್ರೆ 0 ಇಂದ 1 ವರೆಗೂ ವೇರಿ ಆಗುತ್ತೆ. So 0 ಬಂತು ಅಂದ್ರೆ ಅದು ಮಿನಿಮಮ್, so 1 ಬಂತು ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್. So 1 ಯಾವಾಗ ಬರುತ್ತೆ, so sin 90, so sin 90 value is 1, that means B is perpendicular to B, right? When V is perpendicular to B or theta is equals to 90 degree, so F is maximum and that value is QVB, right? So theta is the angle between B and B, so 90 degree andre V is always perpendicular to B, right? So this is for the maximum, right? So in case if they ask for the minimum, for minimum when theta is equals to 0 degree, that is V is parallel to B, right? So ಎರಡು parallel ಇತ್ತು ಅಂದ್ರೆ theta value ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಡಿಗ್ರಿ ಆಗುತ್ತೆ. So hence F minimum that is equals to 0. So if in this case they ask for maximum and minimum, so ಇದನ್ನು ಕೂಡ ಮೆನ್ಷನ್ ಮಾಡ್ಕೊಬೇಕು, right? So the formula is F QVB sin theta. So always it is V cross B. So ಇದು ನೆನಪಿರಬೇಕು ನಮಗೆ, ಅದನ್ನ ಯಾವಾಗಲೂ V cross B ಅಂತಾನೆ ಮೆನ್ಷನ್ ಮಾಡ್ಕೊಳ್ಳೋದು. It will be not B cross B, right? So next 13th question, derive the expression for motional EMF induced in a rod moving perpendicular to uniform magnetic field. So motional EMF means EMF induced at the ends of the conductor which is moving in an uniform magnetic field, right? So that we call as motional electromotive force. So question number 13, right? So consider the uniform magnetic field. So cross mark ಏನು indicates ಮಾಡೋದಂದ್ರೆ magnetic field lines are moving inside the plane of the paper or into the board. So into represents what? The magnetic field B, right? So now generally ಕೆಲವು ಕಡೆ magnetic field ಈ ತರನು represent ಮಾಡ್ಕೊಂತೀವಿ, right? So these magnetic lines, so ಇವೆಲ್ಲ lines ಕೂಡ ಏನಾಗ್ತದೆ, moving inside the board pass ಆಗ್ತಾ ಇರುತ್ತೆ, right? So consider one rectangular loop. So ತುಂಬಾ ಕೇಸಸ್ ಅಲ್ಲಿ ನಾವು circular loop na consider ಮಾಡಿದ್ವಿ. So here we are considering one rectangular loop, so that loop name is PQRS, right? So its length is L and the breadth is X, right? So from Ampere circuital law, right? So ಯಾವ್ದಾದ್ರು ಒಂದು circular loop ಇತ್ತು ಅಂದ್ರೆ, so that will be in the magnetic field. So ಅದು ಯಾವ್ದಾದ್ರು ಒಂದು magnetic field ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ, so ಅಲ್ಲಿ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ನಮಗೆ flux ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, right? So that is from the flux, right? So the total flux, total magnetic field lines passing through any area of cross section. So this is the area of cross section. So into this area of cross section, the number of magnetic field lines are passing. So hence we consider that one as the flux, right? So flux passing through the rectangular loop PQRS. Right, so the rectangular loop consists of the flux and the flux which is in the rectangular loop PQ or S, right? So that is the magnetic flux. So which flux? That is magnetic flux enclosed by the rectangular loop PQRS, that is pi. So from the definition of the flux, so that is equals to BA cos theta, right? So where B is the magnetic field lines and A is the area of the loop and cos theta, right? So here cos theta is the angle between the magnetic field and area element. So theta is 0 degrees, so cos 0 is 1. So we getting pi B is equals to B into A, where B is the magnetic field and A is the area of the rectangular loop PQ or S. So area is rectangle irodinda L into X, right? So pi B is equals to B into L into X. So capital L is that, right? So pi B is equals to B into L into X, right? So in this rectangular loop we made this PQ arm in movable. So ಇದನ್ನ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, movable arm ಆಗಿ ಯೂಸ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ. So when we move this conductor PQ, so in the magnetic field, so magnetic field ಅಲ್ಲಿ conductor move ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿಗೆ flux ಏನಾಗುತ್ತೆ, ಚೇಂಜ್ ಆಗುತ್ತೆ. Hence the EMF is induced across the ends of the conductor PQ. So PQ ends ಅಲ್ಲಿ ಏನು ಇಂಡ್ಯೂಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ನಮಗೆ EMF ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ when this conductor starts to move. So ಇದು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಮೂವ್ ಆಗಬಹುದು ಅಥವಾ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಮೂವ್ ಆಗಬಹುದು. So as this is moving with respect to x, so ಇದು ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ x ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ನಮಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So the x value is changing with respect to time, then the conductor is moving with the velocity v. So when the conductor is moving in the magnetic field, so hence EMF is induced, right? So EMF induced E, that is equals to, so from the definition of the Faraday law, that is minus L into d pi by minus d pi by dt, right? So this is from the Faraday law of electromagnetic induction, right? So induced EMF is equals to minus d pi by dt. So pi value we know, so E is equals to minus d by dt, so B L x, right? So B constant ಇದೆ, ನಾವು ಅಪ್ಲೈ ಮಾಡಿರೋ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ L ಲೆಂತ್ ಆಫ್ ದ ಕಂಡಕ್ಟರ್ ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ when it is moving inside the magnetic field. So magnetic field ಮೂವ್ ಆಗ್ತಾ ಇದ್ದಾಗ, magnetic field ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದ್ದಾಗ ಲೆಂತ್ ಆಫ್ ದ ಕಂಡಕ್ಟರ್ ಏನಿರುತ್ತೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. So only the variable is x. So x is varying. So when it comes to near, then the x value changes, right? So this becomes x, right? So x value ಏನಾಗ್ತಾ change ಆಗ್ತಿದೆ with respect to time. So these two are constant, so we can take common outside minus bl dx by dt, right? So this change in displacement with respect to time, we call that one as velocity, right? So E is equals to bl v. So this is the motional EMF, right? So V is equals to minus dx by dt. Why minus? So minus because so displacement ಏನಾಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ, ಚಿಕ್ಕದಾಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ. So that's why we are going to take minus, right? So this is the motional EMF. E is equals to BLV, right? So where L is the length of the conductor, when the conductor which is moving in the magnetic field, then at the ends of the conductor EMF is induced, right? So that is the EMF E, right? So E is equals to BL, right? So we need to mention the terms where B is the magnetic field L is the length of the conductor, so X is the breadth of the loop, right? So 3 marks ಕೇಳಿದಾಗ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ನಿಮ್ಮ ಕೈ ಬರೆಯಕ್ಕೆ ಆಗದಲ್ಲ ಇದ್ರೂ ಸೊ ಡಯಾಗ್ರಾಮ್ ಬರ್ಬಿಟ್ಟು ಆ ಟರ್ಮ್ಸ್ ಏನಿದೆ ಅನ್ನೋದನ್ನ ಕೂಡ ನೀವು ಮೆನ್ಷನ್ ಮಾಡಿ. ಈ ಟರ್ಮ್ಸ್ ನ ಮೆನ್ಷನ್ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲಿ ಯಾವುದಕ್ಕೂ ಮೀನಿಂಗ್ ಇರೋದಿಲ್ಲ, ರೈಟ್? So next 14th question, state Ampere circuital law, derive the expression for the magnetic field at a point due to a long current carrying conductor. So Ampere circuital law, the 1 marks kuda statement ಬರ್ಕೊಂಡಿದ್ವಿ. So Ampere circuital law states that the integral value of the magnetic field over any closed surface is equals to mu naught times the total current enclosed in that surface. So that gives for the statement of the Ampere circuital law, right? So Ampere circuital law is stated if we consider any one imaginary surface or any closed surface. So on that closed surface at any point, if you find the magnetic field B, right? So over that length dl, then that is equals to the total current which is enclosed in that surface, right? So if we consider this is the conductor which is carrying current I, so Ampere circuital law becomes, so line integral of B dot dl, that is equals to mu naught I, right? So what is the statement of the Ampere circuital law? So the statement is the magnetic field over any closed surface, right? So this is one closed surface, over any closed surface is equals to mu naught times the net current enclosed in the surface. So ಈ surface ಅಲ್ಲಿ ನಮಗೆ ಎಷ್ಟು current ಬೇಕಾದ್ರೂ flow ಆಗಬಹುದು, right? So if you take I1, I2, I3, I4, then I becomes I net, right? So I net is equals to I1 plus, I2 plus, I3 plus, I4, right? So this is similar to that of the Gauss law. So tumba sala idea that is similar to Gauss law, right? So statement already ಬರ್ಸಿರೋದ್ರಿಂದ so ಅದನ್ನ ನೀವು ಇಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರೆದ್ಬಿಟ್ಟು ನೆಕ್ಸ್ಟ್ ಡಿರೈವೇಷನ್ ನ ಕಂಪ್ಲೀಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. So statement is the integral value, right? Integral value of the magnetic field over the closed surface is equals to mu naught times the net current enclosed in that surface. So simple statement. So ಈ ಫಾರ್ಮುಲಾ ನೆನಪಿಟ್ಕೊಂಡು ಕೂಡ you can write the statement, right? So magnetic field over the closed surface. So initially we are taken only the small element. To the complete polar element, we can take summation of dl or integration of dl, right? So ತುಂಬಾ ಕಡೆ ನಾವು integrations ನ follow ಮಾಡ್ತಿರೋದ್ರಿಂದ we are neglecting the summation. So ಎರಡು ಕೂಡ same meaning but little bit vary ಆಗುತ್ತೆ. So here we are considering the integral. So integral means overall surface. So ನೀವು integral ಮಿಸ್ ಮಾಡಿದ್ರೆ only this part we are going to find the magnetic field, right? So derivation ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ದಾರೆ, what we are going to find means derive the expression for the magnetic field at a point due to a long current carrying conductor. So consider one long current carrying conductor I, right? So at any point we are going to find the magnetic field. So for that we consider one closed surface. So we consider the point P at a distance R from the conductor. So at this point if we are going to find the magnetic field B, right? So magnetic field B we can take common outside. So this is from Ampere circuital law. So a law use ಮಾಡ್ಕೊಂಡೆ ನಾವು magnetic field find out ಮಾಡ್ತಿರೋದು. So that's why we taken the relation integral of B dl is equals to mu naught I, right? So I is the current which is flowing in the conductor. So integral of dl, that is equals to mu naught I. So this is one closed surface. This is in the form of circular shape. So we taken that one as circumference of the circle. So small DL element na add ಮಾಡ್ತಾ ಹೋದ್ರೆ ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಸಿಗುತ್ತೆ so circular path area ತಗೊಂಡ್ರೆ so that is the circumference right so B into 2 pi r that is equals to mu naught I so we are going to find the magnetic field at any point P at a distance r so the magnetic field B that is equals to mu naught pi 2 pi into I divided by r so this is the magnetic field of a straight conductor carrying the current right so statement diagram so mathematical form of the Ampere circuit law just we need to substitute integral of dl value is 2 pi r right so 2 pi r substitute madi from that we can find the magnetic field B right so B is equals to mu naught by 2 pi I by r so next 15th question so state this is 14th question number 14 right so state and explain Lenz's law of induced EMF so ನಾನು 1 marks ಮತ್ತೆ 2 marks ಅಲ್ಲಿ explain ಮಾಡಿದ್ದೀನಿ ಅದನ್ನ right so next 16th question show the voltage leads the current when AC voltage applied to a pure inductance right so ತುಂಬಾ important question ಇದು so question number 16 right so question ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ when inductance is connected to a AC circuit so inductance is nothing but the coil or inductor so consider one inductor of inductance L right where L is the inductance right so this inductor is connected to the AC source right so AC source ಅಂದ್ರೆ always circle ಒಳಗಡೆ ಒಂದು tidal form ನ represent ಮಾಡಬೇಕು right so battery shape ಅಲ್ಲಿ represent ಮಾಡಿದ್ರೆ that becomes DC so ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ right so simple diagram inductor which is connected so inductor having inductance L which is connected to the AC source so it has the voltage V that is equals to Vm sin omega t so inductor ಗೆ ಎಷ್ಟು voltage apply ಆಗ್ತದೆ that is V is equals to Vm sin omega t right next so when the current is flowing in the inductor so current inductor will flow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ so here it produces the EMF that means it induces the EMF that is again from the Faraday law of electromagnetic induction right so EMF induced in the inductor or coil so ನಮಗೆ coil ಅಂತ ಕೇಳಿದ್ರೆ coil inductor ಅಂತ ಕೇಳಿದ್ರೆ inductor so again from the Faraday law of electromagnetic induction E that is equals to minus L di by dt right so this is equation 1 so EMF is nothing but again the voltage right so from Kirchhoff's voltage law so from the Kirchhoff voltage law some of the potential some of the EMF or some of the voltages in the circuit or in the mesh that is equals to IR product so ಇಲ್ಲಿ ಯಾವುದೇ ತರಹದ ನಮಗೆ resistance ಇಲ್ಲ so that's why V plus E that is equals to 0 right so V plus E is equals to algebraic sum of the IR product so IR product ಯಾವುದು ಇರುತ್ತೆ ಇರೋದ್ರಿಂದ 0 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ right so apply ಮಾಡಿರೋ voltage ಏನಿದೆ V that is Vm sin omega t right so from the first equation EMF E so EMF ಅಂದ್ರೆ ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ ಅದು ಕೂಡ ಒಂದು voltage this is not the force this is also the voltage right so that is minus so plus into minus minus L into di by dt that is equals to 0 right so L into di by dt that is equals to Vm sin omega t right so equals in the ಆ ಕಡೆ ತಗೊಂಡು ಹೋಗಿರೋದ್ರಿಂದ plus Vm sin omega t so from that we need di so shifting dt to the RHS right so di is equals to Vm by L into sin omega t into dt. Right? So this is the small current which is flowing in the inductor. So we need to find the total current. So total current means integration. So integration to this equation. So integration on both sides. So integration of di, that is equals to integration of Vm by L sin omega t dt. Right? So nimge maths ಅಲ್ಲಿ ಬರುತ್ತೆ integration. So ಅಲ್ಲಿ clear ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. So integration of di we can write I. Right? So ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇದೆ ಅದನ್ನ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಮಾಡ್ತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ x ಇದೆ. So if we differentiate this x we are getting dx by dt. Right? So integration and differentiation are reversible process. So differentiation ಮಾಡಿದ್ರೆ ನಮಗೆ integration ಬರುತ್ತೆ, integration ಮಾಡಿದ್ರೆ again differentiation ಬರುತ್ತೆ. Right? So dx ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ಏನು ಬರಬೇಕು ನಮಗೆ x ಬರಬೇಕು. Right? So here integration of di we are getting I. So Vm constant, L constant. So ಇವೆರಡನ್ನು ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ Vm by L. So integration of sin omega t dt. So already mention ಮಾಡಿದೆ integration ಮತ್ತೆ differentiation ಎರಡು reversible process ಅಂತ. So sin omega t ನ differentiate ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ d by dt. So ಏನು ಬರುತ್ತೆ ನಮಗೆ cos omega t into omega. Right? So this is differentiation. Right? So same way the differentiation of cos omega t we get sin omega t. So which sign minus sin omega t into omega. Right? So differentiation ಮತ್ತೆ integration ಎರಡು ಕೂಡ reversible process ಇರೋದ್ರಿಂದ sin omega t differentiate ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ cos omega t ಬರುತ್ತೆ. So cos omega t ನ integrate ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಬರುತ್ತೆ sin omega t ಬರುತ್ತೆ. Right? So here one more omega ಇರುತ್ತೆ ಅದೇನಾಗುತ್ತೆ ಇಲ್ಲಿ divided ಬರುತ್ತೆ. Right? So ಇಲ್ಲಿ ನಮಗೆ ಏನಿದೆ integration of sin omega t ಇದೆ. So ನಮಗೆ ಏನು ಬರಬೇಕು cos omega t. ಎರಡು ಎಕ್ಸ್ಟ್ರಾ ಟರ್ಮ್ ಯಾವುದು ಮೈನಸ್ ಇದೆ ಜೊತೆಗೆ omega ಇದೆ. Right? So ಅವೆರಡು LHS ಗೆ ಬಂದ್ರೆ cos omega t that is minus cos omega t by omega ಅಂತ ಬರ್ಕೋಬಹುದು. Right? So ಅದು ನಿಮಗೆ integration ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. But up to now right? So I is equals to Vm by L. So integration of sin omega t that is cos omega t minus cos omega t divided by omega. Right? So I is equals to minus Vm by omega L, or we can write this one as sin of omega t minus pi by 2. Right? So minus cos omega t na ಏನು ಬರೀಬಹುದು sin of omega t. Again this is from the trigonometry. So pi by 2 plus theta, pi by 2 minus theta ಇದ್ರೆ so cos ಆಗಿ change ಆಗುತ್ತೆ. So cos ಇದ್ದಿದ್ದು sin ಆಗಿ change ಆಗುತ್ತೆ. Right? So this Vm is a constant, omega constant, L constant. So we are replacing this with one more constant, that is Im sin of omega t minus pi by 2. So ಎಲ್ಲ ಕಡೆ capital I ತಗೊಂಡ್ವಿ. So change that to small I. So ನಡೆಯುತ್ತಾ ಇಲ್ಲಿ. Right? So I is equals to Im sin omega t minus pi by 2. So compare this relation with the voltage. So V is equals to Vm sin omega t. So ಎರಡರಲ್ಲೂ ಏನು ಡಿಫರೆನ್ಸ್ ಇದೆ ನಮಗೆ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಇದೆ. ಎಷ್ಟು ಡಿಫರೆನ್ಸ್ ಇದೆ pi by 2. So minus pi by 2 ಇರೋದ್ರಿಂದ ನಮಗೆ ಫಸ್ಟ್ ವೋಲ್ಟೇಜ್ ಬರುತ್ತೆ, ಆಮೇಲೆ ಏನು ಬರುತ್ತೆ ಕರೆಂಟ್ ಬರುತ್ತೆ. So if we draw the phasor diagram, so this becomes the voltage. So that is voltage leads the current by time what, that is, so this is I, that is pi by 2. So current ಇಂದ ಇದೆ voltage ಗಿನು. So ಎಷ್ಟು ಇಂದ ಇದೆ pi by 2 ಅಷ್ಟು ಇಂದ ಇದೆ. So ಇದನ್ನ ಈ ತರನಾದ್ರೂ ಬರೀಬಹುದು ಅಥವಾ or ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡಿ, ಯಾವುದಾದ್ರೂ ಒಂದನ್ನು ಫಾಲೋ ಮಾಡಿ. So V I, so pi by 2. That means we are rotated this one. So 90 degree rotate ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? So I LHS ಬರುತ್ತೆ, sorry horizontal ಬರುತ್ತೆ. Why? So B vertical ಬರುತ್ತೆ. Right? So this is the statement voltage leads the current by pi by 2. So in the control, so this indicates what sin omega t minus pi by 2. So this is the final statement or final relation. So ಇದನ್ನ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಬರ್ತಿದೀವಿ, ಅದನ್ನ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ ಈ ತರ ಬರುತ್ತೆ. So I is equals to Im sin omega t minus pi by 2. So here we can write Im is equals to v by omega t. Right? So same voltage lags the current by pi by 2 in case of the capacitor, right? So when capacitor is connected to the source, right? So here one capacitor of having a capacitance C which is connected to the AC source, right? So adunu kuda try maadi. So regular class alla adunu helide. So ಇಲ್ಲಿ question ಅಲ್ಲಿ ಇಲ್ಲ, right? Next, 17th question, derive the expression for the energy stored in a current carrying coil, right? So same diagram, right? So idu steps ಜಾಸ್ತಿ ಇದೆ, but ಏನು ಮಾಡಕ್ಕಾಗಲ್ಲ, but you need to practice. So ಇನ್ನು integration ಮಾಡಿಸಿಲ್ಲ, so ಇದು ನೆನಪಿರಲಿ, integration of sin omega t cos omega t. So cos omega t ನ differentiate ಮಾಡಿದ್ರೆ you can get the sin omega t, right? So differentiation ಆಗಿದೆ. So next, question number 17. So reduce the relation for the energy stored in the coil. So coil having the inductance L. So this is the coil. So ಎರಡು ಕೇಸಲ್ಲಿ same. So previous derivation ಅಲ್ಲಿ ನಾವು AC source apply ಮಾಡಿದ್ವಿ. So here we are applying the DC source, right? So current is flowing in the coil I. So when the current is flowing in the coil, EMF is induced. So already EMF induced ಆಗ್ತಾ ಇದೆ. So due to that EMF, it opposes the change in current which is produced in the coil. So ಇಲ್ಲಿ flow ಆಗ್ತಾ ಇರೋ current ಇಂದ ಏನು induce ಆಗ್ತಾ ಇದೆ, EMF induce ಆಗ್ತಾ ಇದೆ. So induce ಆಗಿರೋ EMF ಇಲ್ಲಿ flow ಆಗ್ತಿರೋ current ನ oppose ಮಾಡುತ್ತೆ. That is change in current ನ oppose ಮಾಡ್ತಾ ಇದೆ. So that EMF is the back EMF. So ಇಲ್ಲಿ produce ಆಗ್ತಿರೋ EMF ನ back EMF ಅಂತ ನಾವು ಕರೀತಾ ಇದ್ದೀವಿ, right? So it opposes the induced EMF which opposes the change in current, right? So that is given by the Lenz's law. So Lenz's law ಹೇಳ್ತಾ ಇರೋದು ಅದನ್ನೇ, right? So that we have the relation EMF E is equals to minus L di by dt. So E is the EMF which is induced in the coil, right? So due to that EMF, it opposes the flow of current in the coil, right? So hence we need extra power to maintain the current in the coil, right? So for that power, right? So power is the work done. That means externally we are doing the work. So hence external work done dW by dt. So small work done to the time taken, we call that one as power. So that is equals to magnitude of E, right? That is V into I, that we can written E into I, right? So power ke relation is that P is equals to V into I, right? So here power, we define that power as rate of change of work done, right? So work done per time taken, right? That is equals to magnitude of E into I. So we have E here, right? So dW by dt, that is equals to, so magnitude irodrinda minus na neglect ಮಾಡಿ L into di by dt into I, right? So LHS dt, RHS dt get cancelled. So dW is equals to Li di. So this is the small work done. So we need to find the total work done, that is total work done to maintain the current in the circuit, right? So total work done, W is equals to integration of dW, right? So dW value ಗೊತ್ತಿದೆ, L into I di. So inductance constant ಇರುತ್ತೆ, current ಮಾತ್ರ ಏನಾಗ್ತಾ ಇದೆ ನಮಗೆ ವೇರಿ ಆಗ್ತಾ ಇದೆ, right? So hence L into integration of I, that is I square by 2. right? So this work done stores as magnetic potential energy, right? Magnetic potential energy, right? So that is U is equals to half Li square, right? So similar now capacitor ಕೂಡ ಮಾಡಿದ್ವಿ half CV square, right? So 3 marks ಅಲ್ಲಿ ಇದು ಕೂಡ ಬಂದಿದೆ half CV square. So this is similar to that of the energy, kinetic energy half mv square, right? So half Li square, half CV square, half mv square. So this is in case of capacitor, this is in case of inductor, right? Inductor or coil, right? So remaining question we will discuss in our next class. Thank you.